Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. So in today's video lecture, I am going to discuss about the Tellegen's theorem. Okay, so here in this Tellegen's theorem, so we have to discuss about what is the statement of Tellegen's theorem and what is the procedure involved in the Tellegen's theorem and what is one problem on Tellegen's theorem. Okay, so here first of all we are going to discuss about the statement. What is the statement of Tellegen's theorem? So in this Tellegen's theorem, so we have to find out the power. So power through the source and power through the elements. Okay, so here so we have to say the statement of Tellegen's theorem is, it states that the sum of instantaneous power consumed by various elements in various branch is 0 for any network. That is the statement of Tellegen's theorem. Okay, so in this Tellegen's theorem, so we have to calculate the power, or all the power across each and every element is always equal to 0, or the power from the source should be is equal to the power through the each and every element. Okay, for example, so here I am taking the one network here. So I am taking the one simple circuit only. So plus minus voltage is V. So this is the resistor R1, this is the resistor R2, and this is resistor R3. Okay, so in this case we have to calculate power from the source, means PS. Power from the source, that is PS is equal to power from the resistor R1 plus power from the resistor R2 plus power from the resistor R3. The power from the source should be is equal to the power across resistor R1, R2, R3. So these things should be equal. Power from the source is equal to the power through the resistor R1, resistor R2 and resistor R3. Or we can also say the total power across each and every element is always equal to 0, means that summation of P is equal to 0. We have to equate this one or we have to equate this one. Okay. So in this case we are having some procedure. So procedure for the Tellegen's theorem is, so here step number 1. So step number 1 is, first we have to find out the total number of branches, or we have to identify the total number of loops in a given electrical network, and then calculate the power across each and every branch. So you can see here power dissipated across each and every branch. So we have to find out the power, right? And after that we have to find out the power from the source, that is PS. PS is nothing but power from the source. That is step number 2. And step number 3 is, there are 2 branches. For example, there are 2 branches, that is power delivering branches and power observing branches. Okay, we are having the 2 branches here, that is power delivering branches and power observing branches. So we have to identify the power delivering branch and the power observing branch. So here we can see, so we have to identify the power delivering branch and power observing branch here. Okay, so that means input power is equal to the output power, right? So after that we have to find out the total power, or we have to justify the Tellegen's theorem. So how we can justify the Tellegen's theorem? So power from the source is equal to the power from the resistor R1 and power from the resistor R2 and power from the resistor R3. Suppose if resistor 4 also is there, that is power from the resistor 4. This should be is equal. So PS is equal to, or power from the source is equal to P1 plus P2 plus P3 plus P4. Okay. So here is the procedure of the Tellegen's theorem. Okay. So the main concept of this Tellegen's theorem is, so we have to calculate the incoming power is equal to the outgoing power. So input power is equal to the output power, that we have to find out. Okay. So here I am taking the one network here. So in this network we are having 10 volt voltage source is there, 3 ohm resistor is there, 6 ohm and 3 ohm resistor is there, right? So here the question is, we have to verify Tellegen's theorem by using the given network. So we have to verify. So how we can verify the Tellegen's theorem? By using Kirchhoff laws, or by using nodal analysis, or by using mesh analysis. We can use any method, we'll get the solution, right? So here the solution of the given circuit is, so we have to find out the power. So before that, first, so I am taking the Kirchhoff laws here. So in Kirchhoff laws, first we have to find out the total number of loops. So total how many loops are there? So we are having the 2 loops. So this is loop 1 and this is loop 2. So we are having the 2 loops here. So 2 loops means, so required currents are 2. So first loop current is I1 and second loop current is I2. So we are having the 2 currents, right? First loop current is I1 and second loop current is I2. So current through 3 ohm is I1, current through 3 ohm is I2, and what about current through the 6 ohm is I1 minus I2. This is current through the 6 ohm, right? And assign the polarities. So this is plus and this is minus. So here also this is plus minus and this is plus minus and this is plus minus. Now apply Kirchhoff laws or apply KVL. So we'll get the first loop equation is, so in this case I am starting from this point. So when I am starting from this point, always we need to take the second polarity. Though the second polarity is plus and the voltage is 10. And for the 3 ohm, second polarity is minus and the voltage drop is 3I1. So minus 3I1. And at 6 ohm, the second polarity is minus and voltage drop is 6 into I1 minus I2. That is equal to 0. Because here there is no more elements, that should be equal to 0. Now here simplify the equation. So 10 minus 3I1 minus 6I1 plus 6I2 equal to 0. So minus 6I1 minus 3I1 minus 9I1. So 10 minus 9I1 plus 6I2 equal to 0. Or we can also write 9I1 minus 6I2 equal to 10. Let us take as equation number 1. So 9I1 minus 6I2 is equal to 10. Let us take as equation number 1. Now apply KVL in second loop. So here we are having the second loop here. Now apply KVL in second loop. So in this case I am starting from this point, so we will go for the clockwise direction. So now the second loop equation is, so minus 3I2 plus, so here I am starting from here. When I am starting from this point, the second polarity is minus 3I2, and here at 6 ohm the second polarity is plus. So 6 into I1 minus I2, that should be equal to 0. Now simplify this equation. So we'll get minus 3I2 plus 6I1 minus 6I2 equal to 0. So 6I1 minus 9I2 equal to 0. Let us take as equation number 2, right? So when we are applying the KVL, we are getting first equation is 9I1 minus 6I2 equal to 10, and the second loop equation is 6i1 minus 9i2 equal to 0. Now by solving equation 1 and 2, we'll get i1 value and i2 value. So here i1 value is, will get 2 amperes and i2 value is 1.33 amperes. Okay, so these are the i1 and i2 values. Okay, now what about current? For example, so at 3 ohm, so first we will find out the current values. At 3 ohm, the current value I1 equal to 2 amperes. At 6 ohm, the current value, so I1 minus I2, I1 minus I2 equal to, so 2 minus I2, so what is I2 value? 1.33, that is equal to, here we'll get 0.667 amperes. Similarly, current through 3 ohm, that is I2, so I2 is equal to 1.33. So these are the current. So current through each and every element. So current through 3 ohm is 2 ampere, current through 6 ohm is 0.667 and current through 3 ohm is I2 equal to 1.33 amperes, right? So now we are having the current values through each and every element. Now we have to find out the power. So how we can find out the power here? So first we have to find out the power from the source. So here the power from the source is equal to V into I1. So already we know the power equation. So power is nothing but product of voltage and current, right? So here power from the source is equal to V is 10 into, we are having current I1 value. So here I1, so I1 is nothing but 2, that is equal to 20 watts. So power from the source. Now we need to calculate the individual power. So individual power through 3 ohm, 6 ohm and 3 ohm, right? So now here at 3 ohm power, so power through 3 ohm is equal to, so already we know the power equation. So V into I or I square R or V square divided by R. Here I am using I square R equation. Okay. So here power through 3 ohm is, so at 3 ohm the current is I1. So that is I1 square into R. In the place of R we are having 3 ohm resistor, that is 3. That equal to, so I1 is nothing but what? 2. 2 square into 3, that equal to 12 watts. That is power through the 3 ohm, that is 12 watts at 3 ohm. Now power through the 6 ohm. So power through the 6 ohm. So P6 ohm is equal to, here also I am using the I square R equation, that is I1 minus I2 whole square into R. R is 6 here. So I1 minus I2 whole square into 6. So what is I1 minus I2? So we are already calculated here I1 minus I2, that is equal to 0.667. 0.667 whole square into 6. So by calculating 0.667 whole square into 6, we will get 2.6693. 2.6693 watts. Here 12 watts and here 2.6693 watts. Now finally at 3 ohm, here at 3 ohm, the power through 3 ohm is equal to, so secondary current I2 square into 3. So I2 value, so what is I2 value? Here we are having I2, that is 1.33 whole square into 3. So here 1.33 whole square into 3, by calculating this we'll get 5.3067 watts. Right, so these are the power. Now according to Tellegen's theorem, power from the source is equal to individual powers, means power through 3 ohm plus power through 6 ohm plus power through 3 ohm, means power from the source is 20 equal to power from the 3 ohm is 12 plus power from the 6 ohm is 2.6693 plus power from the 3 ohm is 5.3067, that is equal to, here we'll get 19.976, means 20 is almost equal to 20. So power from the source is equal to the power from the individual elements, means at 3 ohm plus at 6 ohm plus at 3 ohm. So here finally we can write, hence the Tellegen's theorem is verified. This is the calculation part of Tellegen's theorem. Okay, so thank you one and all.